Well, hello, everybody, and Happy New Year to all our listeners. I hope you've had plenty of clear skies over the Christmas period. We're going to start January's VP as usual by looking at the inner solar system and the planet Mercury. Not really very well placed at the start of January. It's too close to the sun in the evening sky. But after the 7th of January, it slowly nudges away from the sun and is visible some 30 minutes after sunset.
Yeah, it'll be close to Jupiter and Saturn, won't it, at that time?
Yes, so that'll be quite a nice way of identifying it. If you look for Jupiter and Saturn, you'll be able to spot Mercury, hopefully, if you've got a clear enough horizon.
Yeah, on the 10th of January, it remains close to Jupiter and Saturn, and at magnitude minus zero point 0.8, which isn't bad for Mercury. It sets about an hour after the Sun. The greatest eastern elongation occurs on the 24th of January, so that's when it's furthest from the sun in the evening sky, and it'll be magnitude minus zero point 0.5 at that time, setting around 100 minutes after the sun. That's pretty good for Mercury.
It is. It's up for a reasonable amount of time, so might stand a chance of being able to observe it.
Yes.
Okay. Venus, then, the next planet out. This is still a morning object. It currently rises about 1.5 hours before the sun on the 1st of January, and this will get progressively less and less. It's quite away from the Earth now, so it looks distinctly gibbous.
Yes.
If you view it through a telescope, and it's getting quite small. It will come to superior conjunction in a couple of months' time, but it is still a prominent object in the morning sky. A nice event to look out for: a 4% lit waning crescent moon lies 6 degrees west of magnitude minus 3.9 Venus on the 11th of January. That'll be quite nice.
That's lovely, actually. Yeah, I do like it when there is a waning or waxing crescent, if Venus is in the evening sky close to the planet. It's something which really captures your imagination. It's a great thing to try and take a photograph of course.
Yes, it's quite difficult, actually, because they're quite different brightnesses. So I imagine getting the images balanced would be quite tricky.
It's just because you're rubbish at imaging. But yes.
I don't pretend not to be.
No, it can be quite tricky. To get the detail on the moon. That's something which is always quite frustrating with the moon, actually. If you adjust your camera's settings so you actually pick up detail on the lunar surface, often the sky around it is too dark, so you lose that impact which you want to see there. But one thing you can go for, of course, when the moon is just 4% lit, you should be able to pick up the night side of it, which is illuminated by Earthshine.
Yeah, that's always quite impressive. And what's interesting is how Earthshine does vary. It's not the same in every lunation. It can vary not only from phase to phase, but also from month to month. So I think it's one of the nicest things to watch out for with the moon. I always look out for Earthshine if the phase is quite small.
It's actually estimating the darkness or lightness of Earthshine is quite an important observation, because, of course, Earthshine occurs when light is reflected from the Earth onto the night side of the moon, and then it reflects back from that back to the Earth. So it's an indication of how reflective the Earth is, so how much cloud there is in our atmosphere. So it's an indirect way of measuring how much cloud we've got in our skies.
Instead of going outside and looking up, yes.
Yeah, but you can't see the whole planet in one go.
No,
that's the whole
no. Yes, I know. Okay, well, let's move out to the planet Mars then. This has been such a great apparition for Mars.
Yes, it has.
It was really well placed early on in autumn, and it continues to be well placed. It reached its highest position in the evening sky, so due south at around 7 o'clock in the evening at the start of January, and it gets about 48 degrees up in the sky.
That's pretty good, isn't it?
Pretty good. Yeah. And it's still fairly bright. Magnitude minus 0.2 isn't too bad. At the start of January, 10.4 arc seconds. So 6-inch telescopes will be showing surface detail at that kind of size.
That's right. And the North Polar Hood is beginning to sort of edge over from the northern polar region. That's a big sort of cloudy region, isn't it, which covers the North Polar Cap.
Yeah, it's actually been quite extensive before January. And it has. I've seen in photographs. It's got quite a bluish colour, but visually, it's also you've been able to pick up the bluish tint visually as well in the large telescopes.
It's an interesting thing actually, because it is quite easy to mistake it for the North Polar Cap if you're not sure what you're looking at, because it's a bright region on the northern edge of the planet.
Yeah.
So it's sort of. It's a tricky planet, isn't it? If you're not used to Mars, it can really catch you out. There are some very, very good hurdles there to overcome.
Yeah, it throws up a lot of challenges, even if you're a seasoned observer.
Yeah, okay. Well, during January, Mars will be showing a phase, because it can show a phase, and it will appear slightly less than 90% illuminated. And it has an encounter with a first quarter moon on the evening of the 20th of January, the moon appearing 7.3 degrees from the planet just before they set at around 0030 UT on the 21st.
So that'd be nice.
Yes, it will be. It should be really, really quite something to look out for. And again, a nice photographic target, actually. Not quite as dramatic as Venus on the moon, but still pretty good. But later on the evening of the 21st of January, the now 58% lit waxing gibbous moon will lie 6.4 degrees from Mars as darkness falls. So you get a double go at it on the 21st. So hopefully, if there are some clouds about, you will at least see something. But on the evening of the 21st of January, Mag plus 0.2 Mars sits 1.7 degrees north of magnitude plus 5.8 Uranus as well. So that's quite a good planetary conjunction if you've never seen Uranus before.
Now, the other thing that will be interesting about that will be comparing the colours.
Yes.
Because both of them are very, very distinctive. Mars is this sort of coppery orange and Uranus is quite a vivid green. And you know, when you get some binary stars that are very different contrast, it can really emphasise the different colours.
Yeah, that's a good point.
And throw up some interesting colour differences. So it will be interesting to see if Uranus if they retain their colour scheme, or whether they appear more vividly coloured because you've got two objects very strikingly coloured, different colours to compare each other with.
Well, an interesting way to see that, if you have a camera as well, is to point it or have a good enough image scale that you can see both objects well separated, and then do a star trail. So just point it at them and then, without any drive active, allow them to trail across the image, because that spreads the light out and often avoids that situation where you're pointing directly at an object where you basically overexpose it, so you lose the colour. So if you spread the light from that object out across the field of view of the camera, then you will pick up the colour better. So that will be another way to try and pick that out.
Yeah, so that's a nice thing to look forward to. Moving further out into the outer solar system now, Jupiter and Saturn. Well, after their great conjunction last month, although Jupiter and Saturn remain close in the evening sky, they're starting to move away. They're in the first half of January. They're quite near to the Sun until they're eventually lost in the glare towards the end of the month. They're both evening planets, but they are very, very low in the sky now, and we really are reaching towards the very end of the current apparition for Jupiter and Saturn.
Well, we are going to hit it, aren't we? Because solar conjunction for Jupiter occurs on the 28th of January, and for Saturn it's on the 24th of January, so they'll line up with the Sun and be completely lost, reappearing in the morning sky, of course.
Yes, so that's it for the gas giants. The ice giants, Uranus and Neptune, they still continue to put on a show. Uranus, magnitude 5.7, visible in the evening skies in the constellation of Aries. It's actually quite an interesting object to observe visually, because if you've got access to a larger telescope, it does sometimes appear that there are these vague brighter zones and darker cloud bands. But I have to be honest, I'm never entirely convinced whether they're real or an optical illusion. Even though if you do make a drawing and they look like the ones you see in images, it's very hard to know because the disk size is so small. And there's something about that greenish colour of Uranus where your eye slides all over the disk.
Yeah, I know what you mean. It is quite tricky, and it is small. But if you have a bigger telescope as well, you can see some of the moons as well, which are going around
that's right.
it. So that's worth looking out for. One interesting thing about it, at magnitude plus 5.7, that places it in naked eye territory. So, and it's fairly high up at the moment. So it's maybe worth having a go, see if you can actually see it with just your eyes. It's a tricky thing because there are a few stars around there which are of similar brightness. So when I've tried it in the past, I have seen it. I did it on a speciality flight to see the Northern Lights, where all the lights were turned off and the sky was really dark, and I did manage to pick out Uranus. But from the ground, you sort of, from an average location where you can get down to about mag plus 5.5 to 6, you sort of look at it and you think, it's there somewhere, and you see these blobs.
Yeah.
You know, one of them is going to be Uranus, but you can never be absolutely sure.
No, I think that's the trouble. And of course, even in a finder scope or a pair of binoculars, I find the greenish hue quite distinctive. But with the naked eye, I doubt you're going to see any colour at all.
No.
Okay, well, there we are. Still stuff to do for Uranus. Neptune, a little past its best now at the start of 2021. Planet is somewhat compromised because of its position in Aquarius. We're unable to see it at its highest point under very dark sky, truly dark sky conditions. But nonetheless, it's still about in the evening sky and worth having a look at, especially if you've never seen it before.
Yeah. Okay. Well, what about special events then? Well, on the 2nd of January, Earth is at perihelion, so we are closest to the Sun in our orbit. And at that time, we'll be 147 million kilometres away from the Sun, compared to 152 million at aphelion. But of course, we're in the middle of the Northern Hemisphere's winter period, so it doesn't make a great deal of difference. In fact, that's nothing to do with the actual temperature we receive on the Earth. It will have a small effect, but the real influencer on temperature for different hemisphere will be the tilt of the planet,
yes,
and whether the poles tilted towards or away from the Sun.
On the 3rd, we have the quadranted meteor shower. This reaches peak activity at 2:30 in the afternoon, which is obviously in daylight.
Yeah.
But if you watch for the meteors on the night of the 2nd to the 3rd, so this is just the night before, we might see a build up into the peak. So you might see more meteors the night before, given the peak happens in the afternoon of the 3rd.
Yeah, and also if you watch it on the night of the 3rd, 4th, you watch the decline of the quadrantids. It's quite a narrow peak actually for the quads. They're very the build up to the peak is pretty fast. So it's just a few hours wide. But okay, let's go back to the moon then. On the 6th of January, if we have a look at the 51% lit last quarter moon, that's not a popular moon because you have to get up early in the morning to see that one through a telescope. It'll show the straight wall, Rupi's rector. Now that, together with the curving Stag Mountains at the southern end of the straight wall, that's a fault line. It looks huge. It looks like a huge cliff.
It does.
But it's not. It's quite a gentle incline in reality. But the Stag Mountains at the southern end of it form, they look like the handle of a cutlass. So Rupi's rector is actually the blade of the cutlass, and that the Rupi's rector plus the Stag Mountains forms a clair-obscure effect known as the cutlass. So that's something to look out for. But if you want to get a more mainstream clair-obscure effects are basically tricks of light and shadow, then on the 20th, there will be the effects known as the lunar X and V occurring, with peak visibility around about 7 o'clock in the evening on the 20th. And they're quite nice to look out for if you need an excuse to look at the moon, which you shouldn't really need, but they give you an extra push to go and have a look at it and see if you can pick them up. I've often seen pictures, because that time when they're visible is close to the first quarter moon. It's not always exactly at first quarter, it has to be said. There's a different way of measuring when they will occur. But it is close to that. And when people have taken photographs of the first quarter moon, you often see the X and the V shining out at you if you know where to look.
You just have to know where to find them.
That's right, yeah. So on the 25th, staying with the moon, this evening, or in the evening of the 25th rather, a 91% lit waxing gibbous moon will occult the southern 2/3 of Mag plus 5.5 open cluster Messier 35, which is a lovely open cluster in the constellation of Gemini. And that occultation will begin around 2300 UT. So,
yeah, that'll be an interesting one, won't it? Because those stars are quite dim, really, and the moon's brightness will really outshine them.
Absolutely,
especially at 91%. So it'd be interesting to see how many of them you can actually pick out whilst that's going on.
It's surprising what you can see through a telescope, actually, if you, especially if you can catch the dark leading edge of the moon first of all, which is the bit which will be covering up the cluster. So if you could arrange it so the bright bit of the moon is sort of slightly out of the field of view, that might help you a bit there with a high magnification. But it will be interesting.
Yeah. Well, let's turn out to the stars now, because it's the winter in the northern hemisphere is quite breathtaking. We've got dark skies, and we've got really good constellations in the evening sky that are, I think, some of the most easily recognizable constellations that are available to observers on the Earth. And perhaps the most easily recognizable has to be Orion the Hunter. Easily identified because you've got the three stars that form Orion's belt. And at the top left, we have Betelgeuse, and bottom right, we have Rigel.
Yes.
But what people don't often know is that the belt stars form part of an open cluster called Collider 70.
Mm-hmm. It's quite a nice open cluster, actually. It's quite large. So if you're looking at the belt with binoculars, then many of the stars you can see in the field of view will actually belong to that cluster. So that's an easy deep sky object to locate in Orion. The belt is quite amazing, isn't it? Because you've got the three stars there, Mintaka, Alnilam, and Alnitak, and they are of similar brightness. They're not exactly the same brightness, but they're equally spaced along a straight line, and it's a really obvious thing. It sort of really sticks in your psyche, that line.
Yeah, and it's quite, and also it's the furthest right-hand star is slightly off. It's not quite a straight line. That's always amused me.
You're very picky.
I'm very picky.
Okay, well, hanging down from the belt, of course, we have what else but Orion's sword.
Yes.
And there's a faint line of stars. If your sky is dark enough, it doesn't have to be that dark, actually. It does stand out fairly well. But it's a faint line of stars that hangs down from Orion's belt. And that contains a load of stuff, actually. You've got a number of clusters in there. You've got individual stars, and you've got quite a lot of nebulosity glowing away. But the brightest nebula in there, of course, is Messier 42, the magnificent Orion Nebula.
Yeah, which you can see with the naked eye. And I still think that even from a cityscape, although we're quite away from the town centre, if you look at the Orion Nebula, you can tell it doesn't look like a star, does it?
I don't know if that's right.
You can't really see because you've got ancient eyes, Pete. But it definitely it doesn't look stellar to me.
But the problem is, there's a lot of faint stars there, so it naturally creates a mistiness in that region. And I know people say, the Orion Nebula is what you can see with the naked eye, but it remains for me to be convinced. I think the next time you go out, actually have a look at that and see, with hand on heart, see whether you can actually see that nebula in there. I
have done it lots of times, and I'm not convinced just because you can't see it, I'm afraid.
Okay, well, I remain to be convinced then.
One thing we should mention, while still in Orion, Betelgeuse or Betelgeuse, however you want to pronounce it. This is the big red giant star in the shoulder, the top left-hand part of Orion. This is worth keeping an eye on, because last year we saw it. It really did dim quite considerably, and of course, naturally, people were speculating a little ill-informed at times, I thought, that this meant that the star was going to go supernova. Of course, when stars go supernova, they normally brighten, not dim. But
it was rather amusing, actually, because there was an awful lot of people there who were actually saying, yes, I know it's gone off. We're just waiting for the explosion to reach us. And you're thinking, how do you know?
Yeah, were you there when that happened? Yeah, I was. So it was quite amused from that point of view. Subsequent images of it have shown what we suppose was the case. You've got it's puffed out a large dust cloud, and that's obscuring some of the light that comes from it. This dusty shell blocks the light from the red giant. So it'd be interesting to see whether we get another dimming event or whether Betelgeuse remains at about the same brightness over the next month or so.
It did brighten up again to its regular brightness, and then it faded again, I think. So there's definitely dusty activity happening around it. Either that, or it's definitely going to go off as a supernova. No, it's definitely a dusty shell blocking the star's light. But that's one to look out for. I think it's just been remeasured very accurately, actually, because it's often described as being 1,000 times larger than the sun. I think it's now estimated to be about 700 times larger than the sun.
Yeah, and that will have an implication for its distance as well. I think new calculations have shown it's a little bit closer than we thought it was.
Yes, that's right. But, just so long as it's not too close.
No, it's definitely not. If it does go supernova, it would be a spectacular event, but I don't think it would be any danger to the Earth. So
no,
good. Well, sticking with orange giants, red giants, we have another one nearby. If we can use follow Orion's belt northwest to the orange Aldebaran, which marks one eye of Taurus the bull.
Oh yeah.
And again, I think this is a lovely star. I think it's a notably different colour to Betelgeuse, but I've always had quite a nice appreciation for Taurus. I think it's an underestimated constellation, and that sideways V pattern that's formed by the Hyades open cluster, I think it's actually quite spectacular. I think if Orion wasn't in the sky, Taurus would be quite a showpiece.
For once, I agree with you. It's
at least we've got that on tape.
Tape. It is a fantastic constellation. The V. I mean, the thing which I think throws a lot of people when they're looking at Taurus is they're looking for a bull, the outline of a bull, and you're not going to get that because it doesn't represent a bull, a full bull. It's actually the V, which is on its side, as Paul described, represents the head of the bull with the join of the two arms, the point of the V, if you like, representing the bull's nose. Then you've got Aldebaran at one end of one arm of the V, which represents one eye, and the star at the other end, which is, if I remember correctly, that's Epsilon Tauri, which is also called Ain, which means eye.
Right.
And a lot of people describe Aldebaran as meaning eye, but it actually means follower. Because it's following the Pleiades across the sky.
Right. So now people have no need to reiterate false myths. We now know it means follower.
But the Pleiades, of course, is that beautiful open cluster, also known as the Seven Sisters.
Yes.
And that represents the shoulder blade of Taurus the bull as he's charging across the sky towards the east. The Pleiades is a young cluster. It's about 3 times the distance of the Hyades. The Hyades is about 150 light years away, so it's one of the I think it is the closest open cluster to us. But the Hyades is much older, so its stars have faded and they've spread out, but the Pleiades is still pretty young, and at 444 light years from Earth, it looks pretty amazing, I have to say.
It does, although I get my best views of the Pleiades with my 10 by 50 finder scope, because even if you put a wide field eyepiece, a low power eyepiece with a wide angle on your telescope, a lot of the stars are still just outside the field of view. So binoculars or a finder scope really just show the Pleiades cluster much better than a telescope, I think.
Yes, I agree with that completely. Okay, well, it's also worth saying that Aldebaran, which looks like it's part of the Hyades open cluster, of course, is only half the distance of that cluster. It's a line of sight effect which makes it appear to be part of the Hyades. Aldebaran is about 65 light years away. But we can use Orion's belt again to go towards the southeast, so extend the line it makes to the southeast to find the brightest nighttime star of them all, which is Sirius, the brightest star in Canis Major, the Great Dog. And it's pretty impressive, actually, because it's so low down that its light gets affected by the turbulent seeing you get at low altitude, and that micro refracts it, so it appears to flicker quite a lot. But you also get the effect known as atmospheric dispersion kicking in as well, which spreads its light into a spectrum of colour. And combined, those two effects cause Sirius to sort of flash these violent colours at you in the night sky. It's really quite impressive.
It is, especially if the jet stream is over us. It really is. It is a very pronounced effect. And you can actually see there are moments, instances of time I've seen when it does look orange, it does look yellow, and then it goes back to steely blue. It's quite. They can be quite striking, the colour changes over a very short duration of time.
Yes.
But Sirius is a binary star, and its companion is a very short, very small star, but very, very heavy, a white dwarf, and it's known as the Pup.
Yes.
And it's actually one of the objects I'm still on my list of things to look out for. And now I've got a larger telescope. I think I might point it at it and see if I can see the Pup this winter.
It's a good time to do it because it's in orbit. It's a 50-year orbit around Sirius, or a mutual orbit between the Pup star and Sirius. And in 2020, the separation is reasonably good, or 2021, I should say, as we've moved into the new year.
Yes.
Let's forget about 2020. The separation is quite good. So this is a good time to try and look for it, and also to try and image it. And I have seen lots of people who've tried to take pictures of it and found a faint star near to Sirius, and they've gone, yes, I've got the Pup. But actually, the separation between them is in the order of the same sort of scale as you'd get with a planetary diameter. So you need to use planetary techniques to do the split between them. And that's where a lot of people fall over, I think, there. But interestingly, if you go above Sirius in the sky and then head slightly over to the left, if I remember correctly, you come to Procyon, which is the brightest star in Canis Minor, the little dog. And interestingly, Procyon also has a white dwarf companion as well.
So we could collect a lot of white dwarf companions over the course of the evening if we put our mind to it.
Yes, indeed. Well, if you draw a line between Procyon, Sirius, and Betelgeuse, then those three stars form a triangle, and that is an unofficial pattern, which is also called an asterism, which defines what's known as the winter triangle. It's not as impressive as the summer version, but it's okay.
It's something to end the evening on, isn't it?
It is, yeah. Okay, well, thank you very much, Paul, for that quick zip around the January sky. If you've got telescope or binoculars that you've been given for Christmas, and then get outside and suffer, as we all have to suffer, the cold and the damp out there. But it's really worth it because the views are incredible at this time of year.
Absolutely.
And the nights are long too, so you've got a good time to do it. So enjoy your sky, and we'll be back next month. Thank you very much, Paul.
Thanks, Pete.